Okay, let's talk about dividing fractions. Now, with division of fractions, the rules are pretty much the same as for multiplying fractions with just one catch. Okay, so as you can see up here, I have the problem 5 divided by 1/2. Now, a lot of people on this one, they think the answer to this is 2.5. Okay, because they're mixing up their rules for multiplication and division. Okay, which we know that, just in case you're wondering, that's wrong. Okay, so when I'm taking 5 divided by 1/2, I'm trying to figure out how many halves are in 5. Okay, now the reason I'm kind of going on this long spiel for division is with the story problems for these ones, like you'll see in a later video, you have to make sure you get the order right. Multiplication, you can mess things up and still get the answer right because order never matters in multiplication. But division, if you don't understand the concept, don't really kind of understand why you're dividing, you can screw things up and get an answer and then not understand why that answer is wrong. So this one, the answer to this is actually 10. Okay, so I got this visual here to kind of illustrate that idea. So here, 5 divided by 1/2. So if you look here, I got 5 equally sized objects. If I cut each of these in half, oh, that was really bad. Let's try that again. Oops, erase, come on. Okay, so if I cut each of these in half, that's close enough. Cut this one in half, cut this one in half, cut this one in half, and cut this one in half, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Okay, so when you look at that, that's a good visual of what division's actually doing, especially when you're dividing by fractions, because it's kind of easy to see with whole numbers, but fractions, I feel like people have trouble seeing it. Now, this method isn't feasible for all the problems we do because you can't draw it out every single time, and it's like, what if you're dividing by something really weird, like, 3/8 or something? That would just take way too much time, and it's not feasible to do that. So that's why we need the arithmetic skills on how to figure out this problem. And the good thing is, there's only one step difference between this and multiplication. So let me show you how this problem's done using basic arithmetic. Get over here. So if I have 5 and I want to divide that by 1/2. And it's important to know these skills for people who have to move up the chain, especially if you deal with equations that have fractions in them. This one in particular is good to know for upper level formula solving and formula manipulation. So first thing we do is we rewrite 5 as 5 over 1. We flip the second fraction, which is called taking its reciprocal. Reciprocal just means flipped, and then we times. So that's the funny thing about dividing by fractions, is there is no actual traditional division. It's just multiplication. I used to have a professor in college that said, there is no division, there's only multiplication of reciprocals, which is true to an extent. So we look at this one. Now again, once we get to times, it's just what we were doing before. We look for diagonal reduction, 5 and 1, nothing, 2 and 1, nothing. So we go ahead and multiply straight across. So we do 5 times 2, which is 10. 1 times 1 is 1, or this just becomes 10. Okay, so let's look at another problem here. Get some more board space. Let's see. But if you kind of compare and contrast this with the other problems we've done, it's really, really, really similar. I mean, even if you have, like, let's do another whole number. Let's do 6 divided by 2/3. Okay, so for this one, again, the same thing. We're trying to figure out how many of these 2/3 are in 6. So we write this as 6 over 1, flip the second fraction, change it to times, so we get 3 over 2. Now we look for reduction. 6 and 2 can reduce, right, by 2. So this gets knocked down to 1. This gets knocked down to 3. Multiply straight across by what's left over. 3 times 3 is 9. 1 times 1 is 1, so we get 9 over 1, which is 9. Okay, let's see if we can do one where we get a fraction answer, because like I don't want you thinking that like every single one of these is going to be a whole number answer. Let's see, what can we do here? Let's do a mixed number. Let's do a whole number and a mixed number. Let's try this one. Let's do 6 divided by 1 1/2. Okay, so we look at this one. Now, just like multiplication, we have to make these both improper fractions first. So you can make 6 over 1, 1.5, it's still going to keep it divided by. That becomes 3 over 2. Okay, now if you can change this and flip it at the same time, more power to you. But just like I said in the earlier videos, I'm going to explain things thoroughly. So for people who need the extra explanation or need to figure out where numbers are coming from, I'll try to keep it as thorough as possible. So now we flip the second fraction. So we get 6 over 1 times 2 over 3. Okay, so now we look for a reduction. 2 and 1, nothing. 6 and 3 can be reduced by 3, so that becomes 1. And that becomes 2. So we multiply what's left over. I got another whole number 1, dang it. 2 times 2 is 4. 1 times 1 is 1, so we get 4 over 1, which is 4. Okay, so you can see some parallels between this stuff and the stuff we've done before. It's just a matter of getting the process down. I mean, depending on which weird numbers you can have, but most likely the ones you're going to run into are whole numbers divided by mixed numbers, or let me go back up, whole numbers divided by fractions. Okay, so very rarely will you have to divide a fraction by a fraction, or a mixed number by a mixed number. It's just situations we don't run into too much. But I mean, other than that, just make sure you remember to flip the second fraction, and then once you do that, all the rules for multiplication come back into play.